Okay, good morning all. So let us continue the discussion that we were into during the last session. So we were talking about what do you mean by language abstraction. Let me first clear a few things from the screen. Okay, so what we were learning about was a thing called as language abstraction. Okay, where exactly this help us is using this abstraction we can create a representation or a model that can model different kinds of computations. And the devices that we seek to represent, the devices known as finite automata, push-down automata, and Turing machine, these computational devices, they will have their root into this abstraction that we are representing. So understanding language abstraction is a key ingredient in order to understand uh, all these devices, basically their composition, their construction, and the design in the later phase. Okay, so I hope these things are, since these things are going to be key ingredient of our discussion, we will pay a lot of attention to the details. Okay, it's a very simple thing, it's not difficult at all. So to begin with, the language abstraction has its basis on these two concepts. Number one is the concept of alphabets, and the other one is the concept of strings. Okay, so in English or any natural language, you have something called as mulakshara, okay, or alphabets. Okay, so for instance, in English, we can talk about this set of symbols from A, B, C, D up to Z. These set of symbols that we use are referred to as the primary symbols using which I can construct any word in English, right? Similarly, in your native mother tongue, there will be some particular set of unique symbols. If it is based on Devanagari, that is, you might be Maharashtrian or you might be Hindi speaking person, then you have Devanagari alphabets. Okay, so these alphabets actually are kind of symbols using which I can represent any word which is valid word in the given language. So similar connection is there with the notion of set called as alphabet to the language abstraction. जो natural language में alphabet का role है, the same role alphabets here are also playing. Okay, that is why this particular subject is very much close to the subject called as uh, natural language processing. This particular subject, if you do well or understand well, then you are ought to understand natural language processing as well in uh, future endeavors or future subjects. Okay, so what is an alphabet? Basically, it's a set of symbols. Now, what can be a symbol? For me, this A, B, C, D can be a symbol. For somebody, the 0, 1 to 9 can be symbols. And for some problems, these letters along with this particular special character hash can be a symbol. For some problems, this particular two set of open and closed parentheses, round brackets, as you call them, can be considered as a symbol. So there are various notions or various ways in which I can understand or I can say something is a symbol or something is not a symbol. Okay, so basically, what constitutes a symbol depends on the problem that you are trying to solve. For instance, if I'm doing binary addition, let's suppose I have two binary numbers. I should use white color. Background is white. So say suppose I'm doing binary addition like this: 1 1 plus 1 0. If this is the addition that I'm trying to do, then my input always going to be a pair of operands. That is this one, and this one, and this 0. Okay. So I have a pair of inputs. So then this 1 1 first input, and then 1 0 the second input, okay, is going to be considered as one pair of symbol for that particular problem. For my problem, it's not the binary alphabet 0 and 1, which I'm terming them as symbols, but I'm terming 1110 as my symbol. So to understand what do you mean by symbol is जो भी computation आप कर रहे हो उस computation में जो unique characters represent होते हैं for representing any valid input or any valid output for that particular problem is referred to as alphabet. So alphabet is technically a set of symbols. That's all. Since it's a set, every element is unique. That is what you need to understand. We saw set theory last week. So you know the notion that set is a collection, and the collection is such that the elements that are part of the collection, they are unique. I can't have multiple entries of same element in the set. That can happen in a list. Okay, fine. Now going ahead, once I know what is a alphabet or what is an alphabet set, what is the notation using which I represent alphabet? The notation that is used is capital Greek letter sigma. So this letter is shown like this. This is not underlined. The only part is this. Okay, sigma. And I may use suffix to indicate different sets. So sigma 1, sigma 2, sigma 3, this way. The same way they have shown it over here. So this is sigma 1, this is sigma 2, this is sigma 3, and sigma 4. Four different alphabets. They can be applied to some different designs of computation. So I may be actually doing some sort of word processing in English. So for that, I would require all the English alphabets that is part of this particular sigma 1. I may be doing some mathematics in base 10, that is decimal numbers, then sigma 2 will be considered as my alphabet set, because any decimal number I can produce using these unique symbols 0, 1, 2 up to 9, right? So that's the notion, that's the understanding of what do you mean by alphabet. Now that we know what do you mean by alphabet, the next level to go and understand language abstraction is to understand what is a string. Now if I have multiple symbols, say suppose one symbol is S1 and the other symbol is S2, I can do an operation called as concatenation operation, which is represented in this particular terminology. The black background and white background is creating problems for me. Sometimes it is black and sometimes it is white. That's why the color thing. So please pardon me about the colors. The important thing that I'm discussing over here is what is a string. So say suppose I have a symbol 1, I'm representing it as SYM1, and I have symbol 2, SYM2. Then there is an operation defined as dot operation between them. What this operation do is, suppose these symbols are the alphabets. So I choose one alphabet for symbol 1, which is R, and second alphabet I choose, or one alphabet I choose, say suppose is 2, and then I concatenate it with another alphabet, that is O. So what I generate is a string EO. That's the notion of what do you mean by a string. I just concatenate multiple symbols from the alphabet set together. Now, for instance, if I have an alphabet set which is equal to, say, sigma 1 is a set that has only one alphabet, that is A, then I can create A from it by not concatenating it with any other symbol. I can concatenate A with A 2 times. I can concatenate A with A 3 times, and I can do this continuously, right? So how many strings I can produce this way? Using this particular operator dot on the set that I have, which is referred to as alphabet, I can produce technically infinite set of strings. Okay, there is one important string that, or important notation, that is called as epsilon. This is the epsilon in Greek alphabet, small e kind of representation. This indicates 0 times concatenation. So if this is A, it means one character concatenation or one symbol concatenation. AA, I'm concatenating A with A 2 times, or 1 time I should say. Okay, so this is, I should say A is repeated once, A is repeated twice, A is repeated thrice. So I'm having 2 concatenations, so A is repeated thrice. I'm having 1 concatenation, A is repeated twice, sorry. I have no concatenation, A is singular. And here, this particular thing, epsilon, indicates that I have not selected anything from the alphabet set. So it's a empty string. So this string is referred to as, in English, if I want to remember, or if I want to name it, this will be called as empty string. Okay. Now every string that I'm able to generate will have different values to a thing called as length of string. How many characters are there, or how many, rather I should use word symbols are there in the string. Depending on that, I will know the length of the string, and this length of the string would matter in some or the other problems. Okay, so length of this string is 1, this string is 2, this string is 3, so on and so forth. Okay, so now we know two concepts. Number one concept is called as alphabet, the other concept is called as string. So how is string created? String is created by composing dot operation on the symbols which are part of alphabets. So from a particular alphabet, the type of or the kind of strings that I can generate will be only using the symbols in the alphabet. No other symbols can be used. So that means from sigma 1, I cannot produce this 1a. Okay, 1a can only be produced if I mix these two alphabets together. That is, I have a set combined with A, B, C, D and 1 at least. So if I want 1a string to be there. Okay, I hope this is clear to you, these two concepts, alphabets and strings. Now, if out of the compositions that I can create using the alphabet symbols, I choose certain things and create a set out of that. This set will be referred to as set of strings from the alphabet. Okay. For example, we'll just go to the next page. Okay. Now this a string over alphabet is a finite sequence of symbols in sigma. Okay. The only thing is that you should remember is finite sequence of symbols attached together using the dot operator or concatenation operator. For example, if I have ABCDZ, then ABFBZ is a string over sigma 1. 9021 is a string over sigma 2, which is of length 4. This is of length 5. And this is a string over this new sigma, and this is a string over sigma 4. Now, this particular set of brackets is not a properly balanced bracket, because if you count the number of open brackets and number of closed brackets, they will not match, and the order also is not correct, because when a balanced string of parentheses is seen, there is always an order to the way the brackets are used, plus the count of opening and closing brackets must also match. So there are two things, or two rules that goes in identifying whether a expression that we have has a balanced string, balanced parenthesis or not, right? So think about it कि ultimately ये जो हमारा representation होने वाला है वो मुझे कोई string किस तरीके का देगा. Okay? If say I have a bigger expression, from that if I eliminate all the other variable names and literal names and operators, ultimately I'll get a string of brackets. And to check whether the brackets are balanced or not, then I need to run certain algorithm that would first test whether the count of brackets are matching or not, and are they in a proper way sequenced. That is, first I have an opening bracket, then I have a corresponding closing bracket for that, so on and so forth. So there are various ways of doing it. We'll learn that later. But to begin with, this is where we start. This is the starting point to understand the representation. Now, ये जो string हमने देखे, ये string क्या represent करेंगे? These string will represent valid inputs or valid outputs for some computation. That is why we are learning this. Okay. Next thing that we need to learn is the concept of language. Now, what is a language? Language is a set of strings over alphabet. तो जो अल्फाबेट से स्ट्रिंग में प्रोड्यूस कर सकता हूँ उनमें से कुछ स्ट्रिंग को मैं अगर सैंपल करूँ तो जो भी कलेक्शन मुझे मिलता है या जो भी सेट मुझे मिलता है दैट सेट इज रेफर्ड टू एज अ लैंग्वेज. सो इनहेरेंटली यू कैन थिंक ऑफ as there can be infinite strings produced from alphabet set, I can produce a language which is infinite in length or finite in length. Okay, depending on whether I choose finite values or I choose infinite values. Now see, this is the way we define sets, right? L1. In English, I represent it like the set of all strings over sigma 1 that contain substring fool. Okay, so April Fool, then Fuller, full toss. So all these things, full toss is spelling alag hai, but all these strings will have substring full. Okay, and there will be a lot of such strings available if I'm talking about sigma 1, which is set of English alphabets, small case A to Z. Okay, I can generate numerous kinds of words in English from these alphabets, and those words, some of them may have fool as their substring, some of them may not have fool as their substring. So what we are doing here is we are collecting all the words which will have FOOL as its part of that particular string, substring. Okay, so substring can be present at the beginning of the string, it could be present at the end of the string, or it can be in between as well. I can have some string generated from the given alphabet set, for instance A, B, F, O, O, L, E. This is not an English valid word, I know that, but it's a string per se from the given set of alphabets. The alphabet is from A to Z, small case letters. So this is one from the set, this is another from the set. So I have sampled 1, 2, 3, 4, 5, 6, 7 values, and I have constructed a string. In this string, this substring is in the middle. Not exactly in the middle, but it is in the in between. It's not at the beginning or it's not at the end. Whereas here, the string FULL or substring FULL, I should say, is at the beginning. Here, the substring FOL is at the end of the string. So I'm just trying to make you understand that there are various properties of these strings. Okay, and we may interest in understanding or learning those properties when we are trying to utilize these strings and abstraction into a formal representation. Okay, so that's what L1 is. The L2 here, it reads that it is a set of all substrings over sigma 2 that are divisible by 7. Now, what is sigma 2? Sigma 2 was 0 to 9, the numerals 0 to 9. These were the symbols. So, if I am making a set of all the numbers which are divisible by 7, it will be multiples of 7. So, in turn, I'm actually making a table of 7. Okay, and that is going to be an infinite set. Right? So you have got an example of infinite set. There are two examples basically, this one as well as this one. Both are examples of infinite set. Okay, I guess this is cut out हो गया वो थोड़ा सा छोड़ दो उसको. Don't worry about that. But L3 is the example of set of all strings over the form S hash S. So now what is S hash S? This string has a very much important property. Here S is representing some substring and S is representing same substring. So start and end is with the same substring, and in between there is an hash. So all the strings that have, say suppose I have A hash A, okay, or maybe my name hash my name, or maybe some, so this, sorry, and maybe something like say, SDF hash SDF. All these things are of the form S hash S. So what it means is the starting substring or the prefix as it is referred to. So this part of the string is generally referred to as prefix, right? English आपको अगर थोड़ा बहुत आता होगा तो आपको पता है इसको क्या बोला जाता है. It is referred to as prefix. Okay. And what is this part referred to as? This part is referred to as postfix or suffix. Okay, it is generally referred to as suffix. Okay, so these all notations or these all symbolic names, they are important in the further discussion. That is why I am actually introducing you to it. So prefix means the starting part or starting substring of a string, and suffix is the ending part or ending substring in a whole string. Okay, so once you know what is a string, the next thing you know is string has a length. Okay, I have a string called as empty string, which is represented by Greek small letter epsilon. Okay, E जैसा जो छोटा letter रहता है वो. Then I have something called as, every string may have certain thing called as substring. Okay, that substring, if it is at the beginning of the string, it is called as prefix, If it is at the end of the string, it is called as suffix. Okay. Can there be any limited length of prefix? Obviously, the maximum length of prefix could be the string length, and maximum length of suffix could be the string length. Okay, पीछे से आगे से देखा जाए तो prefix पूरा string भी prefix ही होगा. One length less is also prefix. Two length less is also prefix. Only one starting letter is also prefix. Okay. For a substring to be prefix, it can be of length 1 up to n if n is length of string. Any substring to be suffix, it can be of at max length n or at max or at min a length 1.